Hey everyone and welcome back. In this video, we are going to tackle some tricky situations you might run into with memory hacking, especially if you're just getting started. The latest update, Pointer Finder 2.0, is packed with new features. But the start of the show is the capture state button. We will get to why it's so powerful in a minute, but first let's start with a familiar friend, the PCSX2 emulator. Before we can find any pointers, we need to tell the tool where to look for the game static data. So head up to the Tools menu and you should be able to find a new option called Static Range Finder. Now, this window will look different depending on which emulator you're using. For PCSX2, it's a piece of cake. It's basically a one-click process. Just make sure to read the info in this window and then hit Find Static Range. And there you go. Now keep in mind, this range isn't 100% guaranteed. It's a very good guess. If you run a scan and find absolutely nothing, you might need to come back and tweak this range a bit. But for now, it's a great starting point. Click Apply and Close. Sweet. Alright, let's find a simple pointer chain that I've already figured out for this video. We will start with this classic live scan method. Click New Pointer Scan. In this first box, you'll put your dynamic address, the one that changes, like your health or ammo. For max level, you're just making an assumption. A good starting point is 3. Max offset is usually fine at its default, but if you find nothing, you can try increasing it to 4 apps if you want. Max results is the number of paths this tool will find before stopping. Again, the default is fine, but you can crank it up if you are not getting any hits. The static range is already filled in from our last step, so we're good there. Now, what about these checkboxes? Scan for structure base looks for pointers with negative offsets. These aren't always reliable, so it's best to leave this off for now. But this next one, search using 16-byte alignment, is crucial for PCSX2. You see, PS2 memory is often neatly organized in 16-byte chunks. Checking this makes the scan way faster and more accurate. It's highly recommended unless you're doing a really deep, exhaustive search. Once that's set, click OK. Now, to narrow things down, you can click Refine with New Scan and input new address for your health from a different level. Then after that, you can use Filter Dynamic Paths. Just click that button and then you can move around the new game. You'll see the list of pointers shrink as the tool automatically filters out all the false positives. Just be aware that if you load a save state where the final address is completely different, the filter will wipe out your results. Okay, so if the live scan works, why do we even need the new state-based algorithm? Well, the classic live scan struggles with finding longer, more complex pointer chains. It has to check every single possibility within the offset and level limits you set. It's still great for simple pointers or when value don't move much. But for the tough stuff, we need something smarter, and that's where the capture state algorithm comes in. It's often 10 times faster and it doesn't really care how high you set the max level or offset. I got this really tough to find variable that in the past I had to use complex alt groups and other tricks to get it to work. But with this new tool, I was able to find the full stable pointer chain for it. So here's what you need to do. Take your dynamic address, paste it into slot 1 and hit capture. Great, now go do something in the game to make the address change, like reload the level or load a different save state. Whatever it takes, just grab the new address and paste it into slot 2 and hit capture. You can do this for slots 3 and 4, but 3 is usually enough for me. Now, for the settings, like I said before, this algorithm doesn't really care about max offset or max level. The most important setting here is candidates per level. This number is the real limiting factor. It determines how many potential paths the scanner explores at each level of the chain. You can set max level to 15 and the max offset to 4 apps or even more. Sounds crazy, but it's totally doable because the candidates limit keeps the search focused. Max candidate path is also critical. You'll want this set high, like 10 million, because the number of potential paths explodes after level 3. If you open the debug console, you can actually watch this happen. Now, this stop when first path found option is just a quick and dirty option to get a fast result. I don't really recommend it for serious work, but it's good for testing. Now, this last checkbox, find all path levels, is very important. By default, this algorithm is built for speed. It stops as soon as it finds the shortest possible path. but sometimes the shortest path isn't the most stable one. By checking this, you tell it to keep searching all the way up to the max level. This is especially crucial for consoles like the Wii, where games use tons of different pointer paths to access the same data. Let's test it out. I'll set candidate per level to just 1 and see what happens. And there it is, a full valid pointer chain in less than a second. If you don't get any results, just go back and bump up the number of candidates. The more you add, the slower the search. But most pointers don't need more than 15 candidates per level, so it should be fun. And remember, max candidate path is a hard limit. If your scan suddenly stops in the middle, it's probably because you hit the limit. Okay, now let's move on to a more complex console. Unlike the PS2's 16-byte alignments, the Wii is based on 4 bytes aligned, which makes finding pointers much harder. The old live scan is pretty much useless here for anything complex. In this example, I'm trying to find Mario's life counter in Super Mario Galaxy 2. I know this is the right address because when I change it to 1, Mario is not looking too happy. Let's fix that for real quick. Great. First we need the static range. Head back to Tools, Static Range Finder. For Dolphin, it's a little bit different. You need to provide a file called main.dol, and here's how you get it. In Dolphin, right-click on your game, go to Properties, then the File System tab, right-click on the top entry, Data Partition, and choose Extract System Data. Save that file somewhere on your computer, then head back to the Pointer Finder window. You'll notice this weird slider here. It's because the main.dol file tells us where the game's code ends. But in memory, there's often more static data loaded after that point. This slider adds a buffer to create a safer search range. The default of 1024 kilobyte is good, but 512 kilobyte is often a nice sweet spot. If you find nothing, you can always come back here and increase it. For some rare games, this jolt might not work at all, so keep that in mind. Click Apply and Close. Now you know the drill. Open the state-based scan window and starts capturing your states with their dynamic addresses. I'll set my options like this and hit OK. Nice, 2 paths found, but they are not basically stable. They are using stack pointers, and as soon as Mario spends, they point to something entirely different. This is why the Find All Paths Levels checkbox is so important. Let's check that, set our next level to 6, and try again. Much better, we have a lot more results. Let's use the filter button to weed out the unstable ones while I move Mario around. Okay, that's bad. Spinning still wiped them all out. Not a problem. When that happens, all you have to do is to refine your search. Let's go back to the state capture window and increase our candidates per level to 4 and try one more time. There we go. These chains don't seem to flickering at all. We can pick the best one we see fit, like the smallest chain or offset. This one here looks promising. Now let's test it. Works on the world map. Works on the starship. Perfect. We find a stable, reliable pointer. So this is how you can find pointer chains for even the most complex systems without ever needing to touch a debugger. It's all about observation, observation, and using the right tool for the job. Thanks a ton for watching, and see you in the next one.